بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 3.5 Implicit Differentiation. Let us first understand what do we mean by implicitly defined functions. So we usually, up to now, we have seen functions solved for y like this or like this. These functions are explicitly written, so you can understand that from here, y is a function of x. This is explicitly written. Okay, y is a function of x because it is solved for y. So y is a function of x. What if the equation is written like this? If the equation is written like this, then it is not solved for y and it's not solved for x. So you don't know whether y is a function of x or x is a function of y. So we can assume always in our in this section that y is would be a function of y, would be a function of x, y is a function of x, and we can actually find, so we can say here that this equation defines implicitly y as a function of x, okay, because it's not explicit, it's not solved for y. The question would be how to find the derivative, how to find dy by dx in such equations. So we have two methods. Either we solve this equation for y and then find dy by dx, but actually for this equation it's very hard to solve it for y. Sometimes it's not possible even to solve the equation for y. So we need to find dy by dx without solving the equation for y. And that's what do we call implicit differentiation. So we do what? We differentiate both sides of the equation with respect to x because we need to find dy by dx. And then we solve the equation, the resulting equation for dy by dx. Let us see an example. Here, for example, we have this equation x squared plus y squared equals 25. If we find the derivative with respect to x, so the derivative of x squared with respect to x is 2x plus the derivative of y squared with respect to x. Now y is a function of x, okay? Y, for example, is sine x, okay? Y, for example, is e to the power x. Whatever, it's a function of x. It is x to the power 3 plus 1, okay? So y is not x, it's a function of x. So how to find the derivative of y squared? We use chain rule. So the derivative of y squared would be 2y times y prime or dy by dx. So you can write it y prime or you can write it dy by dx equals the derivative of 25 is 0. And now you solve this equation for dy by dx and you find dy by dx. So if you take negative 2x to the other side, it would be negative 2x. And then you divide by 2y. So dy by dx would be negative x over y. So that's y prime. Now the question, find an equation of the tangent to the circle at the point 3, 4. Well, the equation of the tangent line is y minus 4 equals y prime or dy by dx at 3, all right, times x minus 3. This is always the equation of the tangent line. So we need to find y prime at 3. Well, y prime at 3 is dy by dx at x equals 3 because x here is 3. But in dy by dx, I have x and I have y. So I need to replace x by 3 and also y by 4 because y is 4 because f of 3 is 4. So now this would be negative. X is 3 and y is 4. So that's the slope. So instead of writing here y prime at 3, I can write it dy by dx at x equals 3 and y equals 4. So the answer would be, the equation of the tangent line would be this equation. You can solve it for y, or you can leave it like this. This is the equation of the tangent line. Another example, let us find y prime. Y prime means dy by dx. All right. We do what? We find the derivative implicitly. We use implicit differentiation. We find the derivative with respect to x. The derivative of x cubed is 3x squared. But the derivative of y cubed, y is a function of x. All right. So we use the chain rule. Derivative of y cubed is 3y squared times y prime, or dy by dx, equals 6xy. Now x times y, this is product. So we need to use the product formula. F times g, the derivative of f times g is f prime times g plus f times g prime. So 6, let me take 6x as f and y as g. So the derivative of 6x is 6 times y plus 6x times the derivative of y. The derivative of y is y prime, okay, because y is a function of x. So the derivative of y is y prime. So now I have this equation, and to find y prime, I need to solve this equation for y prime. How to solve it for y prime? Any term that has y prime, I'll take it to the left hand side. And any term without y prime, I will take it to the right hand side. Y, now I can take y prime as a common factor from all the terms in the left hand side. And finally, I can find y prime by dividing by the coefficient of y prime. So y prime would be 6y minus 3x squared over 3y squared minus 6x. The question, find the tangent. So this is part A. Part B, find the tangent to the volume of Descartes x cubed plus y cubed equals 6xy. This is called volume of Descartes, this equation, at the point 3, 3. All right, so it is y minus 3 equals slope times x minus 3. And the slope, m, is y prime, okay, at x3 and y3, or at the point 3, 3. So this would be equal to 6 times 3, 18, minus 3 times 9, because 3 square is 9, 27, over y square is 9 times 3, that's again 27, minus 6 times 3, that's 18. So actually this will give you minus 1. 18 minus 27 over 27 minus 18 will give you minus 1. So the equation is y minus 3 equals negative x minus 3, or if you solve it for y, negative x plus 3, and plus 3, it would be plus 6. So this is the equation of the tangent line. Find y prime. We have x and y inside the equation, so we use implicit differentiation. To find the derivative of the left-hand side with respect to x, I need to use chain rule. The derivative of sine, the outer function sine, the derivative of sine is cosine. Then I multiply by the derivative of the inner function. Derivative of x with respect to x is 1. dx by dx is 1. But derivative of y is y prime, or dy by dx, equals. Now in the right hand side, I have product. Derivative of y squared is 2y. And remember that y is a function of x. So using chain rule, I need to multiply by y prime. This is the derivative of y squared. times cosine x plus y square times the derivative of cosine x, which is negative sine x. If you want to say times x prime is dx by dx, and it is 1. Now I need to solve this equation for y prime. So as we mentioned, all the terms with y prime, I'll keep it in one side. So here I need to expand. I'll have cosine x plus y times 1, okay, plus y prime times cosine x plus y. And here I have 2y prime cosine x minus y square sine x. So let me y prime cosine x plus y, keep it in the left hand side, and take this term which has y prime also to the left hand side, and then keep negative y square sine x here in the right hand side, and bring cosine x plus y to this side. And now I can take y prime as a common factor, and I keep this as it is, and I can find y prime by dividing both sides by the coefficient of y prime. So this is y prime, this is the derivative. Now what if he asks about the second derivative? Well, we find the first derivative and then we find the second derivative. Find the second derivative here. So let us start by by differentiating this equation with respect to x for the first time. So the derivative of x to the power 4 would be 4x to the power 3. The derivative of y to the power 4 would be 4y to the power 3 times y prime, because y is a function of x using the chain rule. Derivative of 16 is 0. Now I can find y prime from here. I can solve this equation for y prime and then find y double prime. And if you like, you can find the derivative, okay? You can differentiate this function again. And let me do it like this, okay? So differentiate this function again. So 3 times 4 is 12x squared plus. Now here notice that I have two product of two functions, 4y cubed f y prime is g. So the derivative of 4y cubed is 12y squared times y prime, because y is a function of x, times the second function which is y prime, okay, plus 4y cubed times the derivative of y prime, and that's y double prime, equals to 0. So I can find y double prime from here easily, okay. I can keep this term, which is 4y cubed y double prime, in the left hand side, and take the other terms to the right hand side. Here notice y prime times y prime, I can write it y prime to the power 2. So y double prime would be negative 12x squared negative 12y squared times y prime squared over 4y cubed. But the only thing here, and you have y prime with y and x, everything here. But if you want to remove y prime from here, you need to solve this equation, the first equation for y prime. Okay, so let us do it in the other way for us to learn. So y prime from the first equation would be equal to negative 4x cubed, okay, over 4y cubed. And this would be negative x cubed over y cubed. And now to find y double prime, I use the quotient rule. Y to the power 3, I raise it to the power 2, so I will have y to the power 6. Derivative of the numerator is negative 3x squared times y cube minus. Derivative of the denominator is 3y squared times y prime times negative x cube, or I just write x cube and make this plus. So this is y double prime. Also, y double prime here is written in terms of y prime, but you can replace y prime with this, okay, with this formula to write it in terms of y only. So let us, this is 1 and this is 2, and let us make sure that 1 equals to 2. So let me continue equation 1, equation 2 here. It is negative, let me divide, okay? Uh, so negative, I have negative 3x squared y cube over y to the power 6, distribute the numerator over the denominator, and I have 3y squared x cube over y to the power 6 times y prime, and y prime is negative x cube over y to the power 3. All right, so here I will have negative 3x squared over y to the power 6 minus y3. I will have y to the power 3 here minus, there is a minus sign. 3, now I have y3 times x cube would be x to the power 6. And y squared, I will have y to the power 9 below and y squared, so I have here y to the power 7. So I can say that this is y double prime. This is 2. Okay, let me call this 2, not this one. And now let me prove that 1 in fact equals to 2. So equation 1 equals negative, let me also divide negative 12x squared over 4y cube minus 12y squared over 4y cube times y prime square. Well, y prime is negative x cube over y cube squared. All right. So I have negative 12 over 4 is negative 3 x squared over y cube. And you can say that this is the first term in 2. Okay, now minus 12 over 4 is 3, and y squared over y cube is y. 3 minus 2 is 1. And I have here x to the power 6 over x to the power y to the power 2 times 3 is 6. So this would be equal negative 3x squared over y cube minus 3x to the power 6 over y to the power 7, which is equal to equation 2. And so you can see that using any of the two methods, you will get the same answer. This is the end of this section. Hopefully you enjoyed implicit differentiation.